Assalamualaikum and hi everyone. So today we are going to continue with topic 7, which is on file processing. We are going to look into file input and also file output. The objectives on this topic are you should be able to use file object to get information about a file, include a JFileChooser object in your program to let the user specify a file, write bytes to a file and read them back from the file using FileOutputStream and FileInputStream, write values of primitive data types to a file and read them back from the file using DataOutputStream and DataInputStream, write text data to a file and read them back from the file using FileWriter, PrintWriter, and FileReader and BufferedReader. You should be able to read a text file using Scanner. We are going to cover all of this in this topic. What is a file? File is regarded as a collection of bytes. When a file is read, computer delivers some of those bytes to the program. When a file is written, computer accepts some bytes from the program and saves them in part of the file. Computer makes no distinction between an image file and also a text file. It's all bytes to the hardware. What those bytes are used for is up to the software. All information in any file is kept in binary form. File can be categorized as text or ASCII file or binary file. A text file is a file that contains bytes that represent characters A through Z, characters small letter a through Z, characters 0 through 9, the space character, punctuation and symbols, and also a few control characters that represent end of lines, tabs, and some other things. So these texts are using ASCII codes. A binary file is a file that contains bytes that represent others, for example, numbers, image, audio, and formatted text. For example, the letter A can be represented as 01000001 in binary. You can refer to the ASCII table for the whole list. The file class is from java.io can be used to obtain information about file. To do this, we must first create a file object. A file object can represent a file or a directory. For example, you can write it as file in file equal to new file and the name of your file, sample.dat. If you look at the Java API, at the constructor, you are actually creating a new file instance by converting the given path name string into an abstract path name. That means that you are creating a file object, not creating a file. Similarly, you can create a file object that is called inFile in the directory. For example, here in the C directory, you call sample programs and the file name is test.dat. Remember that to use the file class, you have to write the import statement. So you should write import java.io.file. There are many methods that are available in file. You can check the Java API for the whole list. Some of the example, so here we have exists. It can be used to see if inFile is associated to a real file correctly. There are also isFile and isDirectory methods. So these methods are used to check if inFile is associated to a file. If it is false, it is a directory. You can test it directly if it is a directory by using isDirectory method. To list all the names of the files in the directory, you can use the for loop. It uses the method called list. To see the size of the file in bytes, you can use the lang method. To get the name of the file, you can use getName method. To see if the file is associated to a file that exists and can be read, you can use canRead method. To see if the file is associated to a file that exists and can be written, you can use canWrite method. The methods canRead and canWrite are of type Boolean, so it will give you the output as true or false. On online learning, I have uploaded this file called file1.java. Try and run this code. So in this code, it covers all the methods that I have described. The JFileChooser class, a Java X-Swing JFileChooser object, allows the user to select a file. Try and write this code. JFileChooser, chooser equal to new JFileChooser. And then write chooser.showOpen dialog now. It will show you the home directory. To start the listing from a specific directory, you can write the directory inside the brackets. For example here, from the D directory. If you try and run the code, this would appear. Currently, my document is the home directory. What do you think would happen when you click on any files and click Open? Currently, nothing would happen when you choose the file because we haven't set it to do anything. In this code, we have set that if the user selects Open, a message dialog will appear that says Open is clicked. Otherwise, a message dialog that says Cancel is clicked will appear. To get the selected file, you can use the method called getSelectedFile. To get the current directory, you can use the method called getCurrentDirectory. Try and run the code from your online learning in the file called file1.java. The one that is being highlighted, you can see that I have written getSelectedFile.getName. So that will display the name of the file that is being selected. Similarly, to get the name of the directory, then you can use getCurrentDirectory.getName. It will display the name of the directory. To get the path of it, you can use getCurrentDirectory.getPath. Try and run this code and see what would be the output of it. This slide shows the full code inside file1.java. So it covers all the methods that we have looked at. Input-output streams. To read data from or write data to a file, we must create one of the Java stream objects and attach it to the file. A stream is a sequence of data items, usually 8-bit bytes. Java has two types of streams, an input stream and an output stream. An input stream has a source form which the data items come, and an output stream has a destination to which the data items are going. So that means that output stream is to write and input stream is to read. This figure shows the input-output stream where you have the data source, and then you have the input stream where you are reading from the data source, and then the output stream to the data destination where output is you are writing it to the destination and display it. Input-output streams are either character-oriented or byte-oriented. Character-oriented input-output has special features for handling characters data, which is the text file. Byte-oriented input-output is for all types of data, which would be the binary files. The figure on this slide shows the input-output class hierarchy in java.io package. Byte-oriented streams would use input stream and output stream, while character-oriented streams would use reader and writer. Streams for byte, which is the level binary file input and output. FileOutputStream and FileInputStream are two stream objects that facilitate file access. FileOutputStream allows us to output a sequence of bytes, which are the values of data type byte. FileInputStream allows us to read in an array of bytes. In this code over here, we are setting up the file and stream and save some data into it. Going through the code line by line, so the first one, we set up the file and stream. So similar as before, we would write file, out file equal to new file and the name of the file, which is sample1.data. The file can be of any type. If you want to have sample1.txt, that is fine as well. Now, we want to write the data, which is from the byte array, into the stream. We would do that by writing outstream.write byte array. And then after we have done, we can close the stream by writing outstream.close. Then we create our stream object. So over here we write FileOutputStream equal to new FileOutputStream, and it refers back to the file object, which is outFile. To save the data, we would write it to an array of a variable called byte array, and it would have this value 10, 20, 30, 40, 50, 60, 70, and also 80. After you have run this code, you can check whether sample1.data file has been created. The data that we have here, which is the number 10, 20, 30, 40, up until 80, those data are being saved as a byte or binary. If you open the file, it is unreadable to us. It gives us random characters. It does not show the value 10 up until 80 that we expect to see. If we want to see the value of 10, 20, up until 80 to be displayed, we can read the file using FileInputStream. It will display the correct values. The code on this slide shows how you can do it. So here we have FileInputStream inStream equal to new FileInputStream and the name of the file, which is infile. And then we can set up an array to read the data in. We would save the data in byte array variable. Then, to read the data in and display them, we can write inStream.read byte array and then go through the for loop. It will then loop through the array that we have. After that is done, we need to close the stream. We can do it by writing inStream.close. On your online learning, I have shared this file called FileByte.java. In this code, I have combined FileOutputStream and also FileInputStream. If you run this code, it will save the data and then display it on your screen. Try and run this code. What we have learned so far is on byte-level binary file, input and output. So now, we are going to look at streams for data-level binary file input and output. To output the primitive data values, FileOutputStream and DataOutputStream are used. To input primitive data values, FileInputStream and DataInputStream are used. To read the data back correctly, we must know the order of the data stored and their data types. Just to recap what we have been learning in previous topics, so what is a primitive type? Primitive type is the most basic data type. It stores the actual value. For example, we have boolean, byte, char, short, int, long, float, and also double. What is the other data type that we have? So we have the reference type, which store the address to the value. For example, we have string and scanner. Going back to our streams for data-level binary file input and output, a standard sequence to set up a DataOutputStream object. So there are 3 lines of codes that you need to write. So the first one, we would have our file object. which is file, out file equal to new file, and the name of the file. Example here is sample2.data. Then we would save it as byte, so we have file output stream, out file stream equal to new file output stream, out file. To have the data primitive values, we would write data output stream, out data stream equal to new data output stream, out file stream. Remember that output means we are writing it. So what happens over here is, in our out data stream, the primitive data type values are written to our out data stream. And then the primitive data type values are converted into a sequence of bytes, which is at file output stream, out file stream. And then the bytes are written to the file one at a time. So it is being saved in our file that is named sample2.data. And our file object is called outFile. The code on this slide shows that we are writing the values of the primitive data types to the stream. For example, we have outDataStream.writeInt 98765431. That means that we want to write the data of type int, and that's why we use writeInt. If we want to write a data of type char, then we can write outDataStream.writeChar A. So, you need to know the values and also the methods that represent the primitive data types. So if you want to write float, then you would have to use writeFloat method. If you want to write double, then you have to use writeDouble method. After you have done adding all the values, then you have to close the stream by writing outDataStream.close. Now that we have write into the file, how are we going to read whatever that we have written in that file? So to read it, we would use our DataInputStream. The sequence is similar to when we set up the DataOutputStream. In here, we would have our file object called inFile equal to new file sample2.data, which is the file that we are going to read from. And then we have our file input stream, inFileStream equal to new file input stream, inFile. Then we have our data input stream, and we call it as inDataStream equal to new data input stream, inFileStream. What happens here is, it will open the file and bytes are read from the file. And then at file input stream, inFileStream, a sequence of bytes is converted to the primitive data type value. The primitive data type values are then read from the inData stream, which is the data input stream. The code is as shown over here. So you can read the values back from the stream and display them. However, it must be in the same order as when you are saving it. If you look in this code, our first system.out.println is reading the int value. That is because when we save it previously, we have an int value. And then the next line, we are reading long, and then float, double, char, and also boolean. That is the exact order when we save it previously. The order of write and read operations must match in order to read the stored primitive data back correctly. Otherwise, we might get different output. On your online learning, I have shared this file called FileBinary.java. This code shows how to write and read the primitive data types to the stream. Try and run this code to see what would be the output of it. You can also change the code to see what would happen if you change the order of the primitive data. So far, we have looked at how to write and read from file in the sequence of bytes. We have also looked at primitive data values. So now, instead of storing primitive data values as binary data in a file, we can convert and store them as a string data. This allows us to view the file content using any text editor. To write data as a string to a text file, we would use a FileWriter and PrintWriter object. To read the data from the text file, we would use FileReader and BufferedReader classes. We can also use the Scanner class to read the text files. This code shows how to write to the text file. To set up the file and the stream, we would have file_out_file equal to new file sample3.data. And then we have our FileWriter, so we would write FileWriter outFileStream equal to new FileWriter outFile. Then we need to write our PrintWriter, so we would write PrintWriter outStream equal to new PrintWriter outFileStream. And then we would write the values of the primitive data types to the stream. So we would write outStream.println and then any values that we want to be saved. After that is done, we need to close the stream by writing outStream.close. To repeat it again, to store the value as string data, we use FileWriter and PrintWriter. Previously, when we are storing it as primitive data type, we were using FileOutputStream and DataOutputStream. To read from the text file, we have FileReader equal to new FileReader infile. And then we have the BufferedReader, so we would write BufferedReader buffReader equal to new BufferedReader FileReader. To read the first line in sample3.data file, we would write buffreader.readLine. The value in the first line is a string. We can convert the string to an int using integer.parseIn. To read all the values in the file, we can use any while loop or for loop to go through the whole file. On online learning, I have shared this file called FileString.java. So in this example, you can see that to be able to read all lines, I have used the while loop. So what I have written here is while read equal to br.readLine is not equal to null, then it will print out line by line. Another way of doing it is by writing while br.read not equal to -1, which it reads a single character. Try and run this code and see if there are any differences between these two while loops. Run the complete code and see if you can understand line by line. What should you do if you want to append or add more to a file without removing all the content? So if you look at the Java API, the second one, which is FileWriter file boolean append. So you can construct a FileWriter object given a file object and append to it. So you would set the boolean to true. By doing that, whatever that you have in your file will not be removed. The examples that we have seen so far, which is by writing FileWriter and the file, it will remove all the content that we have. Another constructor that we can use is the last constructor, where it says FileWriter string filename boolean append. So you would set the append to true. We can also read the text file using Scanner. So to do it, we need to open the Scanner. So we would have file in file equal to new file sample3.data. And then we have our Scanner. Scanner equal to new Scanner and our file object, which is infile. To get the integer, we would write scanner.nextIn. We would do a similar process for other data type. Remember to always close after you have finished. For example, over here, we would close it by writing scanner.close. The code in this slide shows how to read the whole content of a file if there is another line. So we can use #nextLine and nextLine methods. We can also use #next and next methods as well. To do it, we would write inside our while loop while scanner.hasNextLine, meaning that it will check if there are more lines, then it will read it by going through scanner.nextLine. When there are no more lines, then it will exit the while loop. I have posted the whole code in a file called FileString.java on your online learning. Go through the codes and try and run it. Make sure that you know what those lines are doing. In the code, I have written several scan.nextLine instead of using the while loop. If you use the while loop, then you don't have to write several of scan.nextLine to read the next line in the file. Try and modify the code and change #nextLine method to #next method. See what are the differences between those. Also, see what would be the output if you change next line to next. In summary, we have looked at file object, how to use JFileChooser object, and also how to write bytes to a file and read them back using FileOutputStream and FileInputStream. We have also looked into primitive data types on how to write and read them using DataOutputStream and DataInputStream. We have also looked at how to write text data to a file and read them using FileWriter, PrintWriter, and FileReader and BufferedReader. We have also looked at reading the text file using the scanner. That's all about this topic. So on your online learning, I have posted some MCQ questions and past year's exam questions. Try and answer those. That's all. Thank you.